All right, so here is your quiz. I really, you need to do it first and then see if you did it correctly. So here's your quiz. I want you to grade it with me, okay? So for number one, it says, write an equation for the tangent line. And now it says in slope-intercept form. So I'm going to tell you right now, I'm not going to do that. So if you did the extra steps, God bless you. But we are not going there. We're just doing HK form. You'll see what we do to see what the right answer is. So step one for this is that we need to find the derivative. Now, it doesn't tell you to use limits. So for each function, find the slope of the line tangent. It doesn't say use derivative, so I'm not going to use limits. I'm just going to use shortcut. So that would be 2x. Then I only plug in the x value, which is negative 2. And that gives me negative 4. So what I need to know is the x value is negative 2. The y value is 3. And we just found the slope of the tangent line there, which is negative 4. So if I put it together, the answer for 1a is y equals negative 4, x plus 2 plus 3. Give yourself a check mark. If you went the extra fun step of finding it in slope-intercept form, it would have been negative 4x, negative 8 plus 3, negative 5. So negative 4x subtract 5. So first find the slope, So first find the slope. See if I read correctly. So for 1a, the answer is negative 4. Then b is the equation of the tangent line, which is y equals negative 4, x plus 2 plus 3. So there's those two. All right, let's try it again. Again, I'm going to use shortcuts. So if it tells you to use it using a limit, so be it. If not, we're going to use shortcuts. 2, can you find the derivative here? So we're going to use the quotient rule. So the quotient rule is the bottom times the derivative of the top, subtract the top. I'm going to say the top is negative 3 times the derivative of the bottom, and then the bottom squared. So follow that rule. Then I'm going to plug in 2 and simplify it. So if I plug in 2, this is 0. So if I plug, I only have positive 3 in the numerator. If you plug in 2, there's my only variable left that matters there. I get 2 plus 2, 4 squared. I get 3 over 16. So step 1 is, what's the slope? And the answer is 3 over 16. What's the equation? It's y equals 3 over 16. And then I'm going to use the x coordinate, which is positive 2. So I change the sign, and then I keep the sign. Negative 3/4. Perfect answer. Slope, equation of the tangent line. 4 out of 4, I am sure. All right, here, for each one, find the derivative using a limit. So it tells me I need to use a limit, so I'll do that then. So to find this using limits, the limit, and it's exactly at x equals 1, so I'm going to use the little limit shortcut there. So as x approaches 1, and it's of f at x, which is negative x squared, subtract 5x plus 8, subtract, plug 1 in. So if I plug 1 in, I get negative 1, I get negative 5, and then plus 8, so that's 3. So negative 1, negative 5, that's negative 6, plus 8, so it's negative 2. There it is. And then in the bottom is x subtract 1. I'm going to combine like terms here. So that's negative x squared minus 5x plus 6. Then I'm going to, in order to factor this, I need to factor out a negative 1 from the quadratic. So negative 1 is going to be factored out in front, and then it'll be x squared plus 5x minus 6. Now I'm going to continue to factor this. So factor the numerator here. That's x plus 6 and x minus 1. Notice now the whole divides out. Plug in positive 1, and you get the slope to be negative 7. So 3a, find the derivative of the function, and then evaluate the derivative at the given value. So anyways, that's negative 7. I'll do it differently. The actual derivative then, for this, we're going to use shortcuts here, is negative 2x minus 5. So did you get negative 2x? Subtract 5. Did you get negative 7? All right, number 4. I'm going to go from the other definition of a limit and see if you can get the answer. You can always double check with shortcuts too. So the derivative here, the limit as h approaches 0 of f at x plus h, subtract f at x all over h. There's the original. I'm going to plug in. So first I'm going to plug in x plus h, subtract, then it's just the function. I'm going to use parentheses when I do that. Now I want you to notice that right away the 4's cross out. So 4 take away 4, they're done. I don't need to use them when I combine the fractions. But x and x plus h, I need a common denominator. So the common denominator is going to be x times x plus h. So the first denominator needs an x, top and bottom, and x times 1 is x. The second one needs an x plus h, and I'm subtracting, so use parentheses. And that's all over h. We're almost there as h approaches 0. So next, x take away x is no more. So we just have negative h, and that's over x plus h. And then we're going to multiply times the reciprocal of the denominator and divide out the whole. Now I can plug 0 in. And when I plug 0 in, I get negative 1 over x squared. That's what's left over. So what is the derivative here? It's negative 1 over x squared. Then you're supposed to plug in positive 1. So if I plug in positive 1, the answer here, what's the slope there? The answer is, oh, sorry, I'm supposed to plug in negative 5. Oops, right there. So plug in negative 5, and you get negative 1 over 25. So it is negative and a negative, but the negative squared is positive, but then the negative in front makes it back to negative again. So it's negative 1 over 25. Check mark, check mark. So do you have 8 out of 8? Turn the page. Now we're going to use shortcuts. No more limits. Find the derivative here, and I'm just going to put the answer right here. So what's the derivative for number 5? That's negative 6x squared plus 14x minus 4. Check mark. Number 6, what's the derivative? Well, before I can use derivative rules, it needs to be calculus friendly. No fractions, no radical signs. So this is going to be written as 2x to the negative 4. Now I can do the calculus. So what's the derivative here? And that's 9 plus 8x, and then subtract 1 to the exponent, so it's plus 8x to the negative 5. Perfect answer. Number 7, make it calculus friendly first. So no radical. So how do I write that as an exponent? So 2 is the numerator, 3 is the denominator. And then what is the derivative of that? So the derivative would be 2/3 times 1 in front, so that's 2/3, subtract 1. Remember how we did this? 2 take away 3. That's negative 1/3, and the derivative of 4 is 0. So that's it, 2/3 x to the negative 1/3. 8, I want to simplify this first, if I can, instead of using the quotient rule. So simplify this, so that's 2x squared over x cubed plus 1 over x cubed. So that's 2x to the negative 1 plus x to the negative 3. So doing some basic exponent rules. Now what's the derivative? So the derivative here, negative 1 times 2, and subtract 1 to the exponent. Negative 3 times 1, subtract 1 to the exponent, and you have your answer. Number 9, can you do the product? I'm just going to do, I won't have room to do this in terms of number where the space is. So I'm just going to put the answer here. So it's the first, x squared minus 2x plus 8, times the derivative of the second, plus the second, times the derivative of the first. So know that you did each step correctly, and that's called the product rule. Number 10, when I do the derivative, we're going to do the quotient rule. That's the bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and then the bottom squared. Always feel free, you can press pause if you need to. 10 out of 10, right? Two more left. Number 11 and number 12. The cost for a company to manufacture X units can be modeled by this equation. Find the average rate of change. So to find that, first of all, and then B, find the IROC. So the average from 25 to 100. So that is C at 100, subtract C at 25 over 100, subtract 25. So if I plug in 100, that's 85, take away 80, divided by 75. And that approximately is 0.07. Now what is this? This is cost. So that's 7 cents per unit. So on average, the cost per unit increases by 7 cents. Now, if I wanted to find the, and units matter for you to get the check mark. If I want the instantaneous, I need the derivative. Now, I need to write this calculus friendly, so it's 75 plus x to the 1/2. The derivative of that is 1/2 x to the negative 1/2. So the derivative of 75 is 0. 1/2 times 1, subtract 1 to the exponent, and then plug in, and it says at 800 units. So plug in 800 and answer it. So if I plug 800 in here, the approximate answer is 0.02. So in units, it would be about 2 cents per unit. That's the IROC. So you have 7 cents and you have 2 cents. All right, 12. The height of an object that is thrown straight up from a height of 75 feet above the ground zero, where t is in time, is thrown. So first step is find the average velocity. So to find it, and it's between 1 and 2.5 seconds. So this is a slope formula. Plug in 2.5, subtract, plug in 1, and that's over 2.5, subtract 1. So that is 45, subtract 87 over 1.5. It's okay, the answer is negative. So that means that the object is falling on average. So it's negative 28 feet per second. So did you write down the answer is negative 28 feet per second, and the units matter? The instantaneous rate of change, we need the derivative. So the derivative of this is negative 32t plus 28. So there's the derivative. The instantaneous at 2. So plug in 2, and you get negative 36. And again, units matter, so the instantaneous rate of change exactly at 2 seconds is negative 36 feet per second. What does that mean? Exactly at 2 seconds, the object is falling, and it's falling at that rate. That's what the negative means. 12. So there's actually AB in there, right? So we have, how many questions here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 questions. So you are grading it. Your honor system. You will get an A no matter what you do, lie or not lie. I don't want you to lie to me. So tell me what grade you got out of 18. I'm assuming it's a happy grade out of 18. Take a picture of it, upload it to the assignment. All right? Mr. G Math, over and out. I am proud of you. Keep doing your work. Until next time.